Today we will discuss about the kinematics of a robot. So kinematics basically that is the study of the branch of mechanics. Basically it is dealing with the study of the motion, and here we do not consider the forces which are causing this movement or the motion. Okay, under this the next topic, that is degree of freedom of a rigid body. So why do we need to study this degrees of freedom? Because this is giving us an indication of the flexibility of the robot and correspondingly the applications where we can use our robot. So degrees of freedom of a rigid body in a plane. Okay, that is defined as a number of independent movements it has. So how many number of independent movements the body can make. Okay, that is the degree of freedom. So flexibility, commonly we can call it as. Okay, now in the small xy space, one rigid body is placed. So it is having 3 degrees of freedom. So it means 3 independent movements. So what can it be? Along the x-axis, along the y-axis. Okay, and one is the rotation about its center. Rotational type, x-axis and y-axis. So 3 independent movements. So correspondingly, it is having a 3 degree of freedom. So value that is 3 for the degree of freedom. So this was a 2-dimensional space. Now in 3 dimension or in the space, okay, that was on a plane. Here we are considering a space. So here the degree of freedom. So, first one is along the x-axis. So linear movement along the x-axis, along the y-axis, along the z-axis. 3, then rotational as well. Along the x-axis, along y-axis, along z-axis. So total it gives 6 degrees of freedom. So 3 translating motions and 3 rotary motions. So in the XYZ plane, we can see here the arrows which indicate the translating motion and the rotary motion as well. Now the kinematic constants. These are the constants between rigid bodies that result in a decrease of the degree of freedom of a rigid body system. So we can call it as the limiting factors, the constants. These are the limiting factors. So the term kinetic pair actually refers to kinematic constants between rigid bodies. So they are divided into lower pair and higher pair. So it depends on how the bodies are connected. That we discuss these pairs briefly. So lower pair in planar mechanism. Basically we are dealing with 2-dimensional. Planar, that is basically dealing with 2 dimensions. So one is revolute pair and one is prismatic pair. So revolute pair, that is resembling a rotational motion in the first diagram there in the XY plane. So the movement in the rotational way, that is in the XY plane, that is giving a revolute pair. Then prismatic, that is the linear. Okay, so 1 degree of freedom, just as we discussed here in the previous slide. So along the linear movement, along x-axis, along the y-axis, then a rotational movement. 3 degrees of freedom here we are having in lower pair, in planar mechanism. Now lower pair is spatial mechanism. So spatial, that is covering the 3-dimensional space. Okay, so here we are having spherical pair, plane pair, cylindrical pair, revolute pair, prismatic pair and screw pair. So very brief introduction to each one of them. So in a spherical pair, so 2 spherical centers are kept together. So So two rigid bodies connected by this constant will be able to rotate relatively around x, y and z axis, but there will be no relative translation motion along any of these axes. So only rotational type of motion is there. So degree of freedom, that is 3 in this case. So rotational, one along x-axis, one along y-axis and one along z-axis. Okay, so degree of freedom, that is 3. Now plane pair that keeps the surface of two rigid bodies together. To visualize this, imagine a book lying on a table. Okay, so on the surface of the table. So it can move in any direction on the table only, on the surface of the table only. So two rigid bodies connected by this kind of pair will have two independent translation motions in the plane and a rotary motion around the axis that is perpendicular to the plane. So therefore, the plane pair removes 3 degrees of freedom in spatial mechanism. Okay, so at the example of the book, here we cannot lift up the book. Okay, so that dimension is not there. Only slide it along x, along y and rotate it. So 3 degrees of freedom. Next is symmetrical pair. So here two axes of two rigid bodies, they are aligned. So two rigid bodies that are part of this kind of system will have an independent translational motion along the axis and relative rotary motion around the axis. Translation forward and backward like that, and rotational motion, so twisting type. So cylindrical pair remove 4 degrees of freedom from the spatial mechanism. So out of 6, 4 are removed, only 2 degrees of freedom, that is 2. Next is revolute pair. So the revolute pair keeps the axis of two rigid bodies together. Two rigid bodies constrained by a revolute pair have an independent rotary motion around their common axis. So revolute pair removes 5 degrees of freedom in spatial mechanism. 5 are removed, only 1 is left. Only the rotational. Prismatic, here only translational. The prismatic pair keeps two axes of two rigid bodies aligned and allow no relative motion. So two rigid bodies constrained by this kind of constant will be able to have an independent translation motion along the axis. So a prismatic pair removes 5 degrees of freedom, only 1 degree of freedom is left. Only the translational motion, forward, backward, like that only. Or left, right only we can say. Next is screw pair. So this screw pair keeps two axes of two rigid bodies aligned and allow a relative screw motion. So screw here, we are twisting the screw, rotating the screw. So that is one movement. Then the screw is moving forward, backward. After twisting, either it is going inside or it is coming outside. Okay, so two types of motion. So two rigid bodies constrained by screw pair of motion, which is the composition of translational. If going inside, screw is penetrating the surface, okay, like that we can say it is moving in the translation. Okay, then a rotary motion along, because we are twisting the screw. So therefore, the screw pair removes 5 degrees of freedom in the spatial mechanism. So 5 are removed, 2 are left. Okay, now here, kinematic constants, some detailing about that. So rigid bodies and kinematic constants are basic components of mechanism. So these mechanisms we will be dealing in our robot system. So a constant rigid body system can be a kinematic chain, a mechanism, a structure, or none of that. The influence of kinematic constants in the motion of rigid bodies has two intrinsic aspects. These are the geometrical and physical aspects. Or in other words, we can analyze the motion of the constrained rigid bodies from their geometrical relationship or using Newton's second law. So we will be discussing about them in our next topic. Okay, so I should